I'd like to today go over some questions we get a lot in support. We get this question pretty frequently, and I think it's good to talk about it directly in regards to this tutorial file. So, folks ask, are we automatically accounting for omega factors for beams when a shear wall or some lateral element is landing on it? So this is a really good example because if we look at this model, we have a shear wall right at the front here. And this is our tutorial model, so you can get this right from our website in our tutorial section. But if you see here, we've got a shear wall sitting right up at this front. And if we look down below, there's a beam that is catching that. So a couple things I always like to start with is just to make sure that we understand that we can see directly different floors above, at the same, so you can see the overlay level and you can see where things are landing. So that's super important just to understand your framing is working. The other thing you can do is you can click on that beam itself and see that it is catching that shear wall above. So you can do that by going to the basic loads here, and you should be, and it actually came right to this shear wall, and you'll notice it says roof.sw, which stands for shear wall. And you can see that it's also catching a bearing wall. But if you have that on that selection there, you can see the wind and seismic loads landing directly on top of this beam. So you'll see that it's right now 2,500 pounds that are landing directly onto that beam. And it shows you both sides there, but I just showed the one at one here. So it's nice to see all the things that are landing on it. So there's a beam coming in on this level. That's this beam right here, 1.5. There's some plates, which is going to be your gravity, tributary area loading. And then there's going to be the roof shear wall load right there. So in this case, we can also verify the type of load combinations that are being run on this. So when we come in here, we'll see some of the sizing tab shows us the beam sizes, and then it shows us the calculations that were run. So by default, you'll see that you always get your load combinations as compare all, which is like an envelope of all of these different load combinations. So it's really helpful to see that right there. But sometimes you want to drill down to specifically. So I would like to point out that Lava is automatically running all these load combinations. I didn't have to define them. The program is smart enough to know off the bat that all of these were required because I was using a certain building code. So IBC 2021 was selected, and then it required different load combinations and different load combinations for different things. Sometimes it's for deflection, sometimes it's for, and in this case, we're trying to figure out here this omega factor. So that's what's called EM right there. So if I see here, this is showing that, and I can run just that load combination. I then can come in here and see the details of how this load combination was checked and whether it really governed. So a lot of times it doesn't govern, which is why you may see other ones controlling. And that's why when you look at compare all and you rerun the analysis, you see that it's not listed, but actually it is listed right here. The other thing you can do, if you go to the report section and you just click this button here, this will preview all of the load, the pages we've selected here. And you'll see it's running through all of the different pages. So all of that selected there. If we go into the first few pages, and I'm going to jump to here, this specification page, you'll see here we are running the special seismic cases. And these are here the ones that you're going to see. So that 0.83 times this load combination, these are the ones that are going to be incorporating the omega factors. And those were predetermined when we first started the model. So when we first start the model, we do project definitions, we go over to seismic, and here we define a lot of our factors between the site factors here. And then we also go ahead and say over strength factors and if any other factors that we're going to be including. You get a redundancy factor that is then determined and selected in here in the seismic, whether you're going to be using that redundancy factor. So all of that is automatically taken care of when you get into, so you just make a few selections and then you get to your report and it's now checking that for you. When we get to that beam, if this is controlling, we will see some information on these load combinations that start to control. And you'll note that different things control for shear, for moment, and then for deflection. So different combinations are always going to run through, and you'll see that happens as you go through the beam analysis. So hopefully this is helpful, but we also have this listed in our help file, so you'll be able to see that. If you go into our help file, you can get the tutorial right here, and this will be where you can actually get the model I just worked with. But we also have a section in here to let's go to the lateral section, and in there we have seismic load effects in lava. So this will help you see a little bit more information about how you're going to get that beam calculated there. Thanks for watching the video today, and come visit us at lavabuild.com for more information.